Welcome back. Let's do question 8. In the diagram below, the circle passes through points A, B, C, D, and G. AD is the diameter of the circle. So this is a key point here. AD is the diameter of the circle. What do you think of? You have to think of an angle in the semicircle, or an angle subtended by a diameter. We say an angle in the semicircle, and then that angle is 90 degrees. Okay, BD and AC intersect at H. This is where BD and AC intersect, right? And then angle AGC is 58 degrees. This angle is 58 degrees. We have to check what we are given and also work on our rider, right? We are required to find angle B2. This is angle B2. And then we are required to find angle B1. This is B1. And then we are required to find angle A2, right? And then looking at what we are given, how can we use this information to answer the questions? The clear one is this one. AD is the diameter of the circle. So an angle subtended by this diameter AD is B2. So it means that B2 is what? B2 is 90 degrees. So we have two things so far. We have the angle 58 degrees. We have the angle 90 degrees here. Okay, right? And then we'll be required to find B2. Oh, already that is done. We have found B2. And then B1. Okay, how can we find B1 from what we are given and what we have found? We are given 58 degrees here. We have found that this one is 90 degrees here. Okay, so if you check, this is a cyclic quad. ABCG is a cyclic quad. So meaning what? Meaning that the whole angle ABC is what? Is opposite angle AGC, isn't it? So these are opposite angles of a cyclic quad, so they are supplementary. They must add up to what? To 180 degrees. So we can easily find angle ABC. The whole angle ABC is, that is angle B2 and angle B1, right? We'll find that and then subtract 90 degrees from that. Then we're going to get what? We're going to get angle B1. Okay, the other thing that we need to find is angle A2. How is angle A2 connected to angle maybe B1 or any other angle that we're given? If we check here, we have angles in the same segment. We have this angle here subtended by DC. A2 is subtended by DC, and then also B1 is subtended by DC. So it means angle A2 is equal to angle B1. Okay, you can see this bow tie formed by the green ink there. Okay, so these are angles in the same segment. So now with what we have done so far, I think we can find angles B2, angle B1, and angle A2. Let's just write our answers. 811, we're saying angle B2 is equal to 90 degrees. Okay, this is the angle that is subtended by AD. So this is an angle in the semicircle. And then now we need to find angle ABC. And then after that we can easily find angle B1. Then angle B1 plus angle B2. Okay, angle B1 plus angle B2, that is angle ABC. Right, and then plus the 58 degrees, which is angle AGC. This must give us 180 degrees because they are opposite angles of cyclic quad. Opposite angles of cyclic quad are supplementary, and then means now angle B1 plus angle B2. We know what angle B2 is 90 degrees, so this is 90 degrees, and then plus 58 degrees is equal to 180. Right, we know what angle B2 is, so it's 90 degrees plus 58 degrees is equal to 180 degrees. Right, so angle B1 is equal to 180 degrees minus 90 degrees minus 58 degrees. So angle B1 is equal to 32 degrees. Okay, angle A2 and angle B1 are angles in the same segment. Okay, so angle A2 is equal to 32 degrees. These are angles in the same segment. Alright, the other angles you have to recognize is angle C1 and angle D there. Okay, there are also angles in the same segment. They are subtended by AB. Both they are subtended by AB there. So they should be equal. Angle D and angle C1 are equal. Okay. Alright. If it is given that AB is equal to BC, if AB is equal to BC, right? So what does that mean? It means this angle A3 will be equal to angle C1. That is if AB is equal to BC. Those will be angles opposite equal sides. Prove that AB is a tangent to the circle passing through AH and D. Now let's try to draw this circle. Always have a rough sketch of the circle. So we're saying that prove that AB, this is AB, okay, is a tangent to the circle passing through AH and D. So if AB is a tangent, then means this angle A3 should be equal to angle D there. Okay, right. So what are we given? We're given that AB is equal to BC. So we can say that angle C1 is equal to angle A3. But remember, we talked about this. We say that angle C1 should be equal to angle D, isn't it? Because these are also angles what? In the same segment. Angle C1 should be equal to angle D. Right, so C1 is equal to A3 and also C1 is equal to angle D. So it means therefore angle C1 is equal to angle D, isn't it? Right, so let's say angle C1 is equal to angle A3 because these are angles opposite equal sides. These are angles opposite equal sides. These are angles opposite equal sides. And then angle C1 is also equal to angle D, right? Because these are what? Angles in the same segment. Angles in the same segment, right? And then since angle C1 is equal to angle A3 and then angle C1 is equal to angle D, therefore angle A3 is equal to angle D. Know that if I say x is equal to 2 and y is equal to 2, therefore x is equal to y, because they are just both equal to the same thing, isn't it? Angle A3 is equal to angle C1, angle D is equal to angle C1, therefore angle A3 is equal to angle D. Okay, we can then conclude and say therefore AB is a tangent. AB is a tangent, and then the reason converse tan chord theorem.